Welcome grade 8 to this review video, or in a nutshell video, for Unit 7. Unit 7 was all about parallel lines and angles in triangles and different polygons. And so take a look at the in a nutshell page. That's going to really help. And if you need to take a look at any of the previous videos, please do that as well. As we step through some of the review, and then later on in a future date get to some review questions on these as well. So we've went through a number of things when it comes to angles in this unit. One of the first things is we talked about angles between parallel lines and transversals. And so that was if we have two parallel lines and we have a line going through it, that's called a transversal. We're able to figure out some of these angles that are the same. So let's say I had angle A, B, C, and D, and I also had angle P, Q, R, and S. There are a number of these angles that are now the same. So for example, in this particular shape, I know that angle A, C, P, and R are all the same. So angle A equals angle C equals angle P equals angle R. I also know that these angles, these opposite angles, are the same too. So angle B equals angle D equals angle Q equals angle S. And so we can use that information to help us to solve for whatever is missing. I also know that on any straight line, those two angles equal 180 degrees. So for example, angle B plus angle C equals 180 degrees. I could do that with any. Angle B plus angle A also equals 180 degrees, because that's a straight line. Angle A and D is a straight line. C and D is a straight line. PS, PQ, QR, RS, those are all straight lines. And so when you add those two angles together, you're always going to get 180 degrees. So that was our first bit that we went through. The second thing that we stepped through was particular angle properties when it came to triangles. So if I were to have a triangle, now yes, I extended the line because we actually talked about exterior angles of triangles as well. Let's say this is A, B, C, and this is X here. We talked about how if I add up all of the angles inside, so angle A plus angle B plus angle C, it always is going to equal 180 degrees, no matter what. So we can use that to solve for missing interior angles as well. There's a couple things that we know about angle X. So there's two things that we can solve here. One is that angle C plus angle X equals 180 degrees. The other thing is that angle X, this exterior angle, is going to be equal to the sum of the two opposite interior angles. So angle A plus angle B also equals 180 degrees. So we can use that information once again to solve for different missing angles within triangles using bits and pieces of information that we might already know. From there we went to quadrilaterals. And quadrilaterals refers to any four-sided shape. So let's say we had a four-sided shape here, and we have, let's say, angle A, B, angle C, and angle D. One of the first things off the bat that we talked about is that angle A plus angle B plus angle C plus angle D, in other words, if I add up all the angles in any quadrilateral, any four-sided shape, it's going to equal 360 degrees, no matter what. That's the sum of those interior angles. Then we got to some special types of quadrilaterals. So here, if I had two pairs of parallel opposite sides, the word parallel should give it away. I have what's called a parallelogram. So parallel sides, and there's some interesting things about that. If I just have one pair of parallel, opposite sides. then I have what's called a trapezoid, or a trapezium sometimes it's called as well. Okay, from our parallelogram we can actually split even further. If all the angles are right angles, I have a special type of parallelogram. Now I have right angles as well, though, called a rectangle. If, special one here, if all sides are equal, this one doesn't necessarily have all equal sides, then I have equal sides, equal sides. Then I have what we call a rhombus. And special case scenario, if all sides are equal and all angles are equal, then I have a special shape, special case scenario here, where I have a square. So just a couple of different unique properties of special quadrilaterals, and we can use some of these unique bits of information to solve for what we might not know. The final thing that we got to in this unit in solving things was all about polygons. And the word polygon just refers to a many-sided shape. And so we talked about how a polygon with n sides we call an n-gon. So in other words, 20 sides we would say is a 20-gon shape. There are some that have unique names to them. So for example, a 5-sided shape would be called a pentagon. A 10 would be called a decagon. 8 would be called an octagon. But once we get beyond that, or once we get to some of the stranger ones or numbers, then we just call them their number and then gon after that. A regular polygon have equal sides and equal angles. Okay. We also talked about how the sum of interior angles equals n, the amount of sides, minus 2 times 180 degrees. And the sum of exterior angles, doesn't matter how many sides there are, equals 360 degrees. So hopefully this bit of refresher helps as you step through these different lessons. If there's a particular question, it might not be a bad idea to look back at some of the examples that we did about how to solve questions related to some of these polygons or angles or triangles or quadrilaterals in solving these particular types of questions. Hopefully this helps as you do a little bit of review, as you look back at some of the things that we've learned. Looking forward to some of the review questions coming up.